Hello everybody. Today we're learning about exponential and logarithmic equations, and more specifically we're learning how to solve for these equations. Now our essential understanding, and the thing you need to understand, is to solve any equation for a certain variable we use inverse operations, and that the inverse operation of an exponent is a logarithm and the inverse of a logarithm is an exponent. So if we keep this in mind, it will make it much easier for us to understand how to solve these types of equations. Alright, so here's our first example. It's labeled solving an exponential equation, common base. And it asks us to solve for x. And the equation is 16 to the power of 3x is equal to 8. And the reason why this says common base is if you notice 16 and 8 can both be rewritten as powers of 2. So if we take 16 and we wanted to factor this out, here's kind of an easy way. We know 16 can be factored out to be 4 and 4, and then each of these 4's can be factored out to 2 and 2. So what I can do is rewrite the 16 as 2 to the power of 4, since I have 1, 2, 3, 4 2's. So I'm going to rewrite 16 as 2 to the power of 4, but it still has to be taken to the power of the 3x, which is equal to, and now we could also rewrite the 8 as a power of 2. Well, we should know 8 is 2 times 2 times 2, or 2 to the power of 3, so we can rewrite this as 2 to the third. And then the second thing I want to do is let's go ahead and simplify this right here. If we have a term, 2 to the fourth, raised to the power of 3x, remember that I need to multiply my exponents. So 4 times 3x would give me 12x is equal to 2 to the power of 3. Now, notice that I have the same base. So the base here is 2. The base here is 2. Now, if I have the same base equal to another term with the same base, we know that their exponents must be the same. So for example, let's do another one without a variable. If we had 2 to the power of 4, and I gave you that the base over here was 2, you would also know that its exponent would have to be 4. Otherwise, those sides would not be equal to each other. So now, if we come back to our equation, we can set these exponents equal to each other. So we have 12x and 3, and we can say those are equal to each other. So I'm going to have 12x is equal to 3. And then I'm going to solve for x like I would any other algebraic equation. So inverse operation of multiplication is division. 12 times x, we divide by the 12, and we get x is equal to 3 over 12, which will reduce to 1/4. And there's our solution. So here's a problem that I would like you to try to solve on your own. So go ahead and pause the video, then once you're done with it, press play and I'll show you the solution. Alright, so again here we have two numbers that we can make the same. So notice 27 and 81, we could express those with the same base. If you aren't sure on how to do that, we can look at this. We can try to factor out the 27. Well, 9 times 3 is 27. 9 can be broken down to 3 times 3. And so notice we have all 3's. So we can represent 27 as 3 to the power of 3. So I'm going to go ahead and do that down here. So we have 3 to the power of 3 raised to the power of 3x. And then if I do 81, notice I can break down 81 into 9 times 9, and then both of these 9's can break down into 2 3's. So I have 4 3's, which is 3 to the fourth. So then now I need to simplify the exponents again. So I have 3 to the power of 3 raised to the power of 3x. So again, I'm going to multiply the exponents. So that would give me 3 to the power of 9x is equal to 3 to the power of 4. And if you notice now we have the same bases raised to an exponent. And again, once we have the same base, we can say that the exponents must equal each other. So we can say that 9x is equal to 4. And we can divide both sides by 9 now. And we'll get x is equal to 4/9. Alright, so here's our next example. We have a similar problem, But if you notice, we have the bases as 15 and 285. And if we look into it, we're not going to be able to get these bases to be the same. So we have to use a different strategy. Now, the strategy that we will use comes from our essential understanding. Remember that the opposite operation of raising something to the power of x is taking the logarithm of it. So what I'm going to do is I'm going to take the log of both sides. So I'm going to have 15 to the power of 3x, and I'm going to take the log of that. So the log of 15 to the power of 3x, and then I'm going to take the log of the other side, so the log of 285. Oh, I'm going to keep that in blue. Now remember from last class that one of the properties of logarithms was that we could take the exponent and we could bring it to the front. So now we have 3x, and I'm going to put everything else except for the x in red, so we have 3 times x times the log of 15. And this is going to be equal to the log of 285. Now, to get rid of everything but the x, notice this is 3 times x times the log. So again, thinking of log as just another number, as this is just a number right here. We divide everything but the x. So we divide everything by 3 log of 15. And we do that to both sides. And when we do that, notice that everything will cancel out. 3 divided by 3 is 1. Log of 15 divided by log of 15 is also 1. So we're left with just the x. And that's going to be equal to what the value of this is. And now we just put this into the calculator. And when we do that, we should get a decimal of 0.6958. And let's go ahead and round this to the third decimal. So it would be 0.696. And so there's our answer. Alright, so here's the next problem that I would like for you to work on yourself. So pause this video, and then once you're ready to see the solution, press play. So here we have 5 to the power of 2x is equal to 130. Again, if you look at the bases, we will not be able to get these to be the same, so we have to use the logarithms. So I'm going to go ahead and write log of 5 to the power of 2x is equal to the log of 130. Again, remember I do both sides because whatever I do to the equation I have to do the same to the other side. So I'm going to bring this exponent to the front now because that's again property of logarithms. So I have 2x times log of 5 is equal to the log of 130. And now all I need to do is, since this x is being multiplied by 2 and log of 5, I'm just going to divide by everything. 2 log of 5. And again, I got to do that to both sides of the equation. So the log of 5 reduced to 1, 2 over 2 reduces to 1, and I'm left with just x on this side is equal to log of 130 divided by 2 log of 5, which will give me 1.512 if I round it to the third decimal. Now if you're having trouble getting this from your calculator, this is the way you're going to want to put it in. So you're going to put log of 130, and it'll give you the parentheses, so you have to do the parentheses, divided by, now remember, since this is 2 times the log of 5, you need to put the bottom or the denominator in its own set of parentheses. So it's inside of parentheses. So the denominator is inside of its own set of parentheses, and so we'll have 2 log of 5. And so that 5 will be in its own set of parentheses, but then you have to close in the whole denominator. And if you put it in like that, that should give you the 1.512. Alright, so in this problem, this says, wood is a sustainable, renewable, natural resource when managed properly. Your lumber company has 1,200,000 trees. You plan to harvest 7% of the trees each year. How many years will it take to harvest half of the trees? So what we're looking for is we want to put an equation, and we're looking for how long it will take to harvest half the trees. Well, this is very similar to an interest equation. So we're going to say that the A of t is equal to A times 1 plus r to the power of t. Now, let's go ahead and list our knowns. Now, the A of t, that is how much we will have after so long. So this is going to be half. Well, half of 1.2 million is 600,000, so A of t is going to be the 600,000. Time, we don't know. That's what we're looking for, so the t is the unknown. The little a is what we start out with, so that's 1,200,000. And then the rate is going to be 7%. Now, this is, we're going to take away, so that should be a negative 7%. But when we put it in at the equation, remember we can't put in a percentage, so we have to put it in as a decimal. To do that, we're going to move the decimal places 2 spots to the left, so it'd be negative 0.07. So now let's just plug in everything that we know. So we have 600,000 is equal to 1,200,000 times 1 plus r. Well, here my r is negative 0.07, so it would be 1 minus 0.07 to the power of t. So let's go ahead and do some reducing here. So what I'm going to do first is let's go ahead and divide both sides by this 1,200,000. And we know 600,000 over 1.2 million, that would be 0.5 or 1/2. These will reduce. And then I'm also going to simplify what's in the parentheses. So 1 minus 0.07 will give me 0.93 to the power of t. Now, I just have a simple exponential equation. So again here, now it's simple. Take the logarithm of both sides. So log of 1/2, I'm going to put that as 0.5. And then I'm going to bring the t down. So I have t times the log of 0.93. And now all I need to do is divide by the log of 0.93 on both sides. So now when I do that, these will reduce, and I have t is equal to the log of 0.5 divided by the log of 0.93. And when I do that, that gives me 9.55. So that tells me it'll be almost 9.5 years. 9.55 years until I harvest half of the trees at that rate. Thanks for listening. And this has been your lesson on exponential equations.